Let's continue with more rules of differentiation. Here is the product rule of differentiation. You can find the same product rule in your formula card. The formula says that if you have y, where y is a product of a function ux and another function vx, then to find dy dx, it will be u times dv dx plus v times du dx. Let's illustrate this with examples. We have here an expression y, where y is a product of two terms. So by the side, I'm going to identify u to be the first term, 4x cubed plus 2, and v will be the second one, 1 plus 5x. Then I'm going to differentiate u with respect to x. Applying the first rule of differentiation, 4x cubed becomes 12x squared, plus 2 being constant becomes 0. I do the same for v. I'm going to differentiate with respect to x. 1 being constant becomes 0, 5x becomes 5. Now I'm ready to differentiate. Go back to dy dx. I'll use the product rule formula since what I have here is a product. Applying formula, u times dv dx plus v times du dx. I'm going to expand everything here, and then I'm going to tidy things up. Simplifying, this is what I have. Here we have another expression y, where y is a product of two functions, so I know I have to use product rule. So I'll start by identifying u. Let u be the first function, and v will be the second function. I differentiate u with respect to x. To differentiate this, I need to apply the second basic rule of differentiation from the earlier video. I bring down the power, function remains, power becomes 3, and don't forget to differentiate the function inside. X cubed becomes 3x squared, plus 7 is just 0. I do the same for v. I differentiate with respect to x. X squared becomes 2x, plus 2 is just 0. I'm ready to use the product rule. dy dx is equal to u dv dx plus v times du dx. Okay, now let's tidy things up a little bit. I'm going to do factorization. I look at the first term and the second term. I'm going to take out common factors. The first common factor I recognize is 2. 2 can be found here. 2 can also be found inside 4. So take out common factor 2. Next, x is also common. X is here. X can also be found here. Take out x. Another common factor is x cubed plus 7 power 3. I think that's all the common factors there are. I then will put the rest of the two terms within these square brackets. So for the first term, because I took out 2x, I'm left with, and I took out x cubed plus 7 power 3, I'm left with x cubed plus 7 power 1. And I'm done with the first term. Now we go on to second term. I took out 2, so I'm left with 2 here. I took out x here, so here I'm left with 3x. And I took out x cubed plus 7 power 3 totally. So I'm left with x squared plus 2, which is from here. Let me open up all the brackets here. And then I shall simplify. X cubed plus 6x cubed, that's 7x cubed. This is my final answer. Now let's give this a go. Let's try and differentiate this. Can you recognize what is u and what is v? I will let u be x. That's the first term, first function. And I'll let v be x plus 1 power half. Since it's square root is power half. I do the same. I differentiate u with respect to x. That's 1. dv dx, I will bring down power less 1. And don't forget, go into the function here, x plus 1, and differentiate x plus 1. And that gives me just 1. Okay, now we use product rule formula. dy dx is equal to u times dv dx Now we go and use product rule formula. dy dx is u times dv dx plus v times du dx. Now let me tidy this up a little bit. I have here and this. Since power half is square root and power minus half is square root but in the denominator. What I'm going to do now is I'm going to change this into a fraction involving the same denominator so that later I can combine the two fractions. And to do that, I'm going to multiply this with this so that I create the same denominator as this fraction. I leave the first term unchanged. Then I take the numerator times numerator. Square root times square root, we get power 1. Now that the two fractions have the same denominators, we can combine the fraction. And this is my answer.